When you think about free electricity, you probably imagine solar panels gleaming on a rooftop or a wind turbine spinning on the horizon. Both of those things work, sure. But what if I told you that the single most reliable power generator you could build this weekend isn't sitting above your house at all? It's right beneath your feet, and it doesn't require sunlight, wind, or any moving parts whatsoever. For nearly 2 centuries, this technology has been scientifically documented and proven to work. Yet most people who spend thousands of dollars on battery backup systems have never even heard of it. That's not because it's complicated or unreliable, it's because there's no corporation making a profit from explaining it to you. And that matters more than you might think. Here's the situation most of you are facing right now. Your power company raises rates almost every year. Your fixed income doesn't, so the math keeps getting worse. Some of you are paying over $200 a month just to keep the lights on and the air conditioning running when it's hot outside. That's money that could be going toward your grandchildren, your healthcare, or simply having a little breathing room in your budget. When you look into alternatives, everything costs a fortune. Solar systems run $15,000 to $30,000, even with tax incentives. Battery backup arrays add another $10,000 to $20,000. And by the time you factor in installation, permits, and the replacement costs down the road, you're talking about a second mortgage on something that's supposed to save you money. But there's an angle that almost nobody talks about. It's not about replacing your entire power consumption. That's the mistake everyone makes. They think energy independence means running your whole house off-grid for nothing. It doesn't. What matters is reducing what you owe the power company each month. Even cutting your bill in half saves you over $1,000 a year. Over a decade, that's $10,000 in your pocket instead of theirs. The technology we're talking about works on a completely different principle than solar. It doesn't compete with sunlight. It doesn't care whether it's raining or cloudy or midnight. It's based on something called the galvanic effect, which happens naturally in soil when you bury two different metals in the ground. I know that sounds like science fiction, but it's not. It's so old, so well understood, and so reproducible that it's been used in industrial applications for over 100 years. The reason this matters to you specifically is this. You don't need a sunny location. You don't need to wait for good weather. You don't need to climb on your roof or deal with contractors. You can build a working version of this in your backyard for less than $10. And I mean that literally. You can have it running by tomorrow morning. Now, before you think this is going to power your whole house, let me be clear about what this actually does. A single unit generates between 500 millivolts and 1.5 volts, depending on soil conditions. That's not enough to run your refrigerator, but it's enough to continuously charge a small battery pack. And when you string multiple units together, and you can build 20 of these for the same price as one solar panel, something remarkable happens. The cumulative output becomes useful. You can store that charge in a backup battery and then use it to power your most expensive devices during peak billing hours. Peak hours are when the power company charges you the most. If you can shift even a few kilowatt hours away from those expensive times, you're saving real money. 20 or 30 of these units running continuously gives you the equivalent of a decent home solar system, except it cost you less than $150 total instead of $15,000. The other thing that separates this from other alternatives is resilience. Your solar panels depend on weather. Your grid connection depends on aging infrastructure and power company decisions, but a properly built earth battery array depends on nothing but basic soil moisture and the laws of chemistry. In a genuine emergency, when the power is out for days, this keeps working without any maintenance, without any fuel, without any degradation. That resilience is especially valuable if you're on a fixed income and you can't absorb a major financial shock. One bad storm knocks out power, and suddenly you're spending $500 on a hotel because your house has no cooling and your medications need refrigeration. One major equipment failure with a traditional solar system, and you're looking at a service call that costs $1,000 or more. That doesn't happen with this approach. The worst that can happen is a connection gets corroded, and you replace a wire for $5. Here's the part that most DIY guides skip over, though. It's not because it's dangerous. It's not. It's because understanding the actual mechanism behind how this works changes how you build it, how you maintain it, and most importantly, how much power you actually get out of it. Soil is conductive because it contains dissolved salts and minerals. When water fills the spaces between soil particles, those minerals dissolve partially, creating a medium that can carry electrical charge. When you bury two metals that have different affinities for releasing electrons, you create a voltage between them. The difference might be small in a single cell, but the current, the actual flow of electrons, is continuous. It never stops. Not at night, not when it's raining, not ever. This is where the traditional solar approach falls apart for someone in your situation. You're on a fixed income. You need reliability. Solar gives you inconsistency. Sunny days produce 5 times as much power as cloudy days. In winter, your output drops by 70% compared to summer. Your battery system has to be sized for the worst month of the year, which means you're massively oversized for 9 months of it. And oversizing means spending money on capacity you never use. By contrast, The Earth battery system provides steady, consistent output year-round. Soil temperature doesn't fluctuate dramatically. The moisture content stabilizes after the first few weeks. Your output might vary by 10 or 15% between seasons, but that's nothing compared to the 50 to 70% swings you get with solar. For a system that needs to be reliable and predictable, consistency is everything. Now, there's something critical that the manufacturers and the installers don't want you to understand. The most expensive part of any alternative energy system isn't the generation, it's the storage, the batteries. Those lithium cells that everyone pushes cost thousands of dollars, and they degrade over time. After 5 to 7 years, they've lost 20 to 30% of their capacity. After 10 years, they're barely useful. You don't replace them, you replace the entire system at full price. But here's where this approach is truly different. You're not trying to store days or weeks of power. You're trying to store a few hours. 6 to 8 hours maximum. That's the time window between when power is cheap and when it gets expensive, or between when your solar panels aren't producing and when you most need power. A small battery bank, something you can buy used for a few $100s, is all you need. And suddenly your capital investment is a fraction of what the solar companies want to charge you. The other piece that most guides completely miss is this. You probably already have some battery storage lying around your house. Old car batteries, used deep cycle batteries, or industrial batteries from equipment that's been retired. Most people throw these away or sell them for scrap, but as a storage medium for your Earth battery system, they work perfectly fine. They might not be good enough for a high-performance solar setup, but they're absolutely adequate for this application. I want to walk you through what actually happens when you wire up even a modest array of these Earth batteries. Let's say you build 30 units. You bury them in your yard, spacing them out about 3 feet apart in moist soil. Each one produces about 0.7 to 1.2 volts and a tiny amount of current, but 30 of them, properly wired, gives you a stable 12-volt system producing between 50 and 80 milliamps continuously. That 50 to 80 milliamps might not sound like much, but run it continuously for 24 hours and you're generating 1.2 to 1.9 amp hours every single day. That's roughly 12 to 20 amp hours per week just sitting there in your yard, every single week, regardless of weather. Over a month, that's 50 to 80 amp hours. Enough to charge your phone, run a small light, or contribute meaningfully to a backup battery system that handles bigger loads. When you combine that with even a small solar panel, maybe a 100-watt panel you pick up used for a couple $100s, you have a hybrid system that works all the time. Solar provides the bulk of your power on sunny days. The Earth batteries provide a baseline all day and night. Bad weather? The Earth batteries keep the system generating while clouds block the sun. Nighttime? The Earth batteries are still working. The solar panel hibernates, but the system doesn't care because you've got 2 independent generation sources. This is the approach that makes sense for someone on a fixed income who wants to reduce utility bills without betting the farm on expensive equipment. You're not trying to eliminate the grid tomorrow. You're not spending $30,000 on a system that might be obsolete in 5 years. You're building something practical, something you can expand gradually, something that actually pays for itself within a reasonable time frame. The complete ebook guide I've created on this topic covers all the materials you need, the exact spacing and soil conditions that maximize output, how to wire multiple units for maximum voltage and current, and how to integrate this safely with backup battery systems you might already own. That guide is available in the description and in the pinned comment if you want to go much deeper into the engineering specifics and the build itself. But before we get into the specifics of the build, there's something about this technology that changes everything. It's something the reference materials almost never mention, and it's the reason why you might actually want to start with just 3 or 4 of these units instead of a full array. Most guides treat Earth batteries like an all-or-nothing proposition. You either build a massive array or you don't bother. But that's terrible advice for someone in your position. The reason is that you need to understand your specific soil first. Every location is different. The mineral content varies. The natural moisture retention is different. The depth at which you hit more conductive soil layers varies by neighborhood. By starting with just a few test units, you learn what your site is actually capable of producing. Maybe your soil is naturally quite conductive, and you get 1.5 volts per cell, or maybe it's sandy and dry, and you're getting 0.5 volts per cell. That difference determines how many units you need to reach a specific target output, and it determines how deep you need to dig and how far apart to space them. There's no one-size-fits-all answer. I'm going to be direct with you. The power company doesn't want you to understand that this technology exists. Not because it's dangerous or unreliable, it's neither, but because once you realize that a reliable, maintenance-free power generation system can be built for less than $200 and produce continuous baseline electricity, the entire business model of selling you expensive equipment and service contracts falls apart. I'm not saying there's a conspiracy. I'm saying that information that doesn't generate profit doesn't get marketed. It's that simple. Solar companies make billions. Battery manufacturers make billions. Electricity providers make hundreds of billions. Nobody in that chain has a financial incentive to tell you that you could generate reliable power from buried metal in your yard for $8. So let's talk about what you can actually do with this technology right now. Because understanding Earth batteries isn't theoretical, it's practical, it's actionable, and it starts with a single question. How much baseline power can one buried cell really produce? A single Earth battery buried in moist soil, let's say your backyard after a rain or near your garden, produces somewhere between half a volt and nearly a volt of direct current. That doesn't sound like much when you're used to thinking about household electricity in terms of 110 volts or 240 volts. But here's what matters. That voltage is continuous. It doesn't stop at night. It doesn't depend on cloud cover. It doesn't fade when the temperature drops. It simply runs day and night as long as that soil stays moist. Now, for someone on a fixed income, that baseline matters because baseline power is the power that keeps running whether you're awake or sleeping, whether it's sunny or cloudy. It's the power that never stops being useful. In a traditional grid setup, you're paying for baseline power 24 hours a day whether you use it or not. With an Earth battery system, you're generating it for virtually nothing. But one cell producing less than 1 volt isn't going to run your refrigerator. We need to think about this differently. And this is where the math gets interesting, and where most people either dismiss Earth batteries or suddenly realize they've been sitting on a gold mine. If you wire Earth battery cells together, not in parallel but in series, you add their voltages. So 20 cells, each producing 0.7 volts, becomes 14 volts. 50 cells becomes 35 volts. 100 cells becomes 70 volts. And here's the critical part. You're not adding much cost with each additional cell. A copper rod costs $1 or $2. A zinc rod costs $1 or $2. Burial and connection labor is free. It's your backyard. So the cost scaling is nearly linear. You could reasonably build a 35-volt system with 50 cells for somewhere between $100 and $150. That includes the materials, a basic junction box, and basic wiring. No licensed electrician required, no complex installation, just honest work with your hands in your own yard. And now the question changes. It's not, can I build this? You can. The question becomes, what do I do with 35 volts of continuous baseline power? 35 volts won't run your main refrigerator directly, but it will charge a battery bank. It will run low voltage LED lighting throughout your home. It will trickle charge a 12-volt deep cycle battery, which then becomes your baseline power storage for when that soil dries out slightly or when you want to run something that needs consistent 12-volt power. It will run a radio, it will run a water pump if you have a well, it will power a small fan or air circulator, it will charge your phone and your tablet and your laptop through the right converters. And here's where most conversations about off-grid power stop. They talk about the big stuff, the whole home backup, the air conditioning in summer, the electric heating in winter. Those conversations matter, but they miss the real opportunity for someone on a fixed income. The real opportunity is the baseline. It's the continuous power that costs you money but doesn't make anyone rich if they sell it to you. It's the electricity that keeps your phone charged. It's the power that keeps a small battery bank ready for emergencies. It's the current that runs a circulation fan or a small water pump or backup lighting when the grid goes down. Because that's the vulnerability most people ignore. You're not just worried about your electric bill, you're worried about what happens when the power stops. And for someone on a fixed income, even a few hours without power can mean a lost meal from a thawing refrigerator, a missed medication schedule because you can't charge your electric reminders, a night without light and with no way to communicate with family. An Earth battery system that runs continuously, that costs almost nothing to build, and that requires no maintenance. That's not theoretical. That's survival infrastructure. That's the difference between a manageable situation and a crisis when the grid fails or when your utility bill becomes too much to carry. So let's move beyond the theory and talk about the specific configuration that makes sense for you right now. Because not every system is the same. Your soil quality, your water table, your specific power needs, they all matter. First, soil quality. Not all soil is equal as an electrolyte. Sandy soil is poor. It doesn't hold moisture well, and it has fewer dissolved minerals and ions. Clay-heavy soil is better. It holds moisture longer and has more ionic material. Loamy soil, the kind gardeners love, is ideal. It's a mix that retains moisture without staying waterlogged. If you have sandy soil, you have a choice. You can dig down to find better soil, or you can improve your surface soil with added organic material and water management. The second option is cheaper. Second, moisture management. Your Earth battery doesn't need to be flooded. It needs consistent moisture. In most climates, that's naturally seasonal or can be maintained with simple watering routines. Some people integrate their Earth battery cells into a vegetable garden or around landscaping where they're already watering. Others build a simple rain collection system that naturally feeds their cells. The investment in this is minimal. A bucket, some PVC pipe, basic gravity-fed irrigation. But the payoff is consistent voltage output. Third, spacing and configuration. Cells too close together interfere with each other, the electrical field from one cell affects the others, and you lose efficiency. Standard recommendations suggest spacing cells 2 to 3 feet apart minimum, arranged in a grid or line. Your available space determines your configuration. Someone with a quarter-acre lot can build a much larger system than someone with a city lot, but even a small space, a strip along the side of your house, an unused corner of your yard, can hold enough cells to generate meaningful baseline power. Fourth, depth. This matters more than people realize. Cells buried shallow, just 6 or 8 inches, will perform well in spring and fall when soil moisture is highest, but they'll degrade when soil dries out on the surface in summer or freezes in winter. Cells buried deeper, 16 to 24 inches, experience more stable moisture and temperature. They produce more consistent voltage year-round. The trade-off is that digging deeper requires more work. But digging is free labor if you do it yourself. And honestly, at your stage of life, a slow project over several weekends is often better than a rushed job anyway. Now, you might be thinking, this is good baseline power, but what about when I need more? What about summer when I'm running a fan, or when I have guests and the load increases? This is where you start layering your system. Your earth battery becomes your continuous charging source, not your primary power storage. You take that consistent 35 or 40 or 50 volts, and you direct it toward charging one or more deep cycle lead acid batteries. Lead acid is not fashionable, it's not what the solar installation companies push. But it's cheaper than lithium, it's incredibly durable, a quality deep cycle battery lasts 10 to 15 years with basic maintenance, and it's forgiving. You can overcharge it slightly. You can draw it down completely without permanent damage, and if one cell fails, you can replace that single cell instead of replacing the entire battery. A single 12-volt, 200-amp-hour deep cycle battery, and you can buy used ones for $50 to $100, holds enough power to run a small refrigerator for several hours, or LED lighting throughout your home for a full night, or a laptop and phone charger for a full day of moderate use. 2 of them gives you redundancy and flexibility. 3 of them starts to feel like real security. And the cost for this layered approach? We're talking maybe $400 to $500 total to build a system that generates continuous baseline power and stores enough to keep critical systems running for days in an emergency. That's a month or two of utility bills for most households. And you're not paying that every month. You're paying it once. So the real question isn't whether this works. The real question is whether you're willing to invest a couple of weekends in your own backyard to take back control. And that's where most people hesitate, not because of the cost or the difficulty, but because they're not sure what they'd actually do with it once it's built. Let me be direct about what this system can and cannot do. It cannot run your central air conditioning system. It cannot run your electric heater. It cannot power your main refrigerator continuously without a massive battery bank that would cost several $1,000s. Those loads are simply too large. But here's what it absolutely can do. It can run LED lighting in every room of your house. It can keep a small refrigerator or cooler operational. It can charge every device you own. It can run a fan or air circulator, not whole house cooling, but spot cooling in the room where you're sitting. It can power a television or radio. It can run a water pump or sump pump. It can keep security cameras operational. It can maintain communication devices, phone chargers, internet, emergency alert systems. In other words, it handles everything that matters when the grid fails, and everything that costs you money month after month on the parts of your life that don't require major electrical infrastructure. Here's where most people stop thinking about earth batteries. They see the voltage numbers, they see the small current output, and they assume the story ends there. But that assumption costs you thousands of dollars every single year. Because the real power, and I mean this literally, emerges when you stop thinking about one battery and start thinking about what happens when you wire them together strategically. A single earth battery buried in your backyard produces between 0.5 and 2 volts. That's not enough to run anything useful on its own. But here's what changes everything. When you connect multiple cells in series, meaning you wire the positive terminal of one to the negative terminal of the next, the voltages stack. Connect 10 cells in series, and you're now looking at between 5 and 20 volts. Connect them in parallel after that, and you multiply the current capacity. Suddenly, you have a system that doesn't just measure electricity. It generates it continuously, without degradation, without maintenance, and without ever asking permission from your utility company. The question that changes your life and your retirement budget is this. What's the absolute minimum number of earth batteries you need to cover the essential loads I just described? The answer depends on how much you actually use those loads. A single LED bulb uses about 10 watts. An old-style incandescent bulb uses 60 watts. A typical fan draws 50 to 75 watts. A small refrigerator in standby mode pulls 30 to 150 watts, depending on how often you open it. When you add it all up, say running 3 LED lights for 8 hours a day, a fan for 6 hours, and a small cooler or mini fridge for 10 hours, you're looking at roughly 1 to 2 kilowatt hours of actual consumption per day. That sounds like a lot until you realize what it actually means in terms of earth batteries. 20 earth batteries, wired correctly, producing an average of 100 milliamps at 10 volts, will generate approximately 20 watt hours per day. Sounds small, but multiply that across a year. That's roughly 7,300 watt hours, or about 7 kilowatt hours annually, completely free, completely passive, and completely ignored by the utility company because it's literally just sitting in your yard in the soil. But here's where the geometry of this system gets interesting. You don't need those 20 batteries running all at once to cover your essential loads. You need them running in cycles. A simple relay circuit, something you can build for under $20, can automatically disconnect your earth battery array whenever it reaches full charge, and reconnect it when the voltage drops. That's the same principle that's been in every solar system for 20 years. The only difference is that solar needs the sun. Your earth batteries need nothing except the planet beneath your feet. Now the real conversation starts here, because once you have a working earth battery array, you have choices you never had before. You can choose to run critical loads during peak hours when the utility rates are highest. You can choose to supplement solar or wind during low production periods. You can choose to run your essential equipment even during a blackout, and I promise you, after a multi-day outage, you'll understand why that choice matters more than anything else you own. But the part that really gets people excited is this. An earth battery array costs less than $30 to build. The copper plates cost about $4, the zinc plates cost about $2, the terracotta pots cost maybe $1 each, the wire is probably already in your garage, and the soil, that's free. That's literally everywhere outside your back door. For the cost of a single restaurant dinner, you've installed a power generation system that will run for the next 30 years without a single replacement part, without a single service visit, and without a single apology from an energy company about why your bill went up again. The math here is brutal for the utility company. If you install just one array in your backyard, again, less than $30, you cut your essential backup power costs to zero. If you install a second array in a different location on your property, you've added redundancy for another $30. If you install a third in a raised bed or a container garden, you've built a system that could theoretically run through a multi-week power outage with nothing but basic maintenance. And here's the part that costs the utility company sleep at night. There's nothing new about this technology. It's not experimental, it's not vaporware, it's not some Tesla-inspired fantasy that requires a PhD to understand. Earth batteries have been generating measurable electricity since before your parents were born. A German engineer named Daniel Eckermann documented them in 1894. The technology was used in remote telegraph stations across America in the 1920s because it was reliable, it was cheap, and it didn't require coal or oil. Then rural electrification happened, the grid expanded, and earth batteries became a historical footnote instead of a standard tool. But here's what's changed. You're on a fixed income, the grid is less reliable every year, the utility company has zero incentive to make your bill smaller, and the technology that was perfectly sufficient to power communication stations across the American frontier is still perfectly sufficient to keep your lights on and your essential devices charged when the system fails. This is not about going completely off-grid, this is not about fantasy or ideology. This is about taking concrete steps to reduce your dependence on a system that's designed to extract money from you without ever giving you more reliable service in return. Every earth battery you install is a vote with your money. It says, I'm not paying for a third outage this year. I'm not letting my backup power costs triple because a lithium battery manufacturer decided to raise their prices. I'm not sitting in the dark waiting for a truck that might show up sometime next week. The complete guide to building a full earth battery backup system, including the wiring diagrams, the relay configurations, the soil preparation, and the troubleshooting steps that will save you hundreds of hours, is available in the description and pinned comment. It walks you through every single decision, from placement to capacity planning to integration with any other power sources you already have. But before you go build your system, there's one more thing you need to understand, because the real value of earth batteries isn't the $30 you spend up front. It's the thousands of dollars you stop sending to the utility company over the next decade. It's the peace of mind when the power goes out and you know, with absolute certainty, that you have light, communication, and cooling running from technology that doesn't depend on anyone else's grid. Think about your current situation. How much are you spending right now to have backup power that doesn't really work? How much did your last power outage cost you, not in money directly, but in the stress, the lost time, the food that went bad, the medication that needed refrigeration? Now multiply that by the number of outages you've experienced in the last 5 years. That's your real cost. That's the bill the utility company doesn't send you because they're too busy sending the other one. An earth battery system doesn't prevent those outages. Nothing will, but it makes them irrelevant to your life. When everyone else is sitting in the dark wondering when power will return, you're reading, your fans are running, your cooler is holding food, your phone is charged, and your family is safe and comfortable. And you accomplish that not by spending $15,000 on a professional solar installation. You accomplished it by spending less than $100 on materials and a weekend of your time doing something you're completely capable of doing yourself. The Earth batteries don't care whether it's day or night. They don't care whether it's sunny or cloudy. They don't care whether there's been a wind gust or 6 hours of calm. They work in conditions where every other backup power source fails. And they get better over time, not worse. Because the more minerals and salts accumulate in the soil around them, the more conductive the electrolyte becomes. That's the opposite of lithium degradation. That's the opposite of a technology that gets weaker with every charge cycle. If you want the complete technical guide to sizing your system for your specific home and your specific loads, with the relay wiring, the surge protection, the grounding specifications, and the soil preparation protocol that maximizes conductivity, get the ebook from the description or the pinned comment. It's the resource that takes you from curiosity to installation, and it answers every question that will come up when you're actually building this system in your backyard. Your retirement is supposed to be about freedom. Freedom from commuting. Freedom from stress, freedom from decisions being made by other people. But that freedom doesn't mean anything if you're still paying $200 a month to keep the lights on and worry about what happens when the system fails. Earth batteries give you a third option. They're not a replacement for everything, they're a replacement for panic. They're a replacement for paying for reliability you don't actually get, and they're a replacement for the feeling that your energy security depends on a system that doesn't care about you. The utility company wants you to believe that energy independence is expensive, complicated, and only for people with engineering degrees. They want you to believe that backup power requires debt, installation crews, and ongoing service contracts. What they don't want you to know is that for less than $100 and a weekend of work, you can build a system that works for 30 years without asking permission, without paying premiums, and without ever letting you down when it matters most. Thank you for watching Fixed Income Power. I hope this changes how you think about that patch of dirt in your backyard. If this video helped you understand Earth batteries and how they fit into your energy independence plan, please subscribe, like this video, and hit the notification bell so you never miss a new upload. Your next video is going to cover something equally powerful: how to integrate Earth batteries with a small wind generator for truly redundant power. I'll see you there.